first thing we're going to talk about is a couple of different types of cooking methods and different things that you're going to see when you're working on appliances. Even when you're working on a stove, there's different terminologies used, whether you're cooking on the top of the stove, whether you're using the oven and you're baking in the oven or you're broiling in the oven. And back in the 80s, they came out with something we call induction cooking. So we have 4 types of cooking, and when I studied, it really was only 3. You have conduction, you got convection, you have radiation, and you have induction. Those are the 4 types of cooking. When I first studied back in the early 80s, they didn't really have induction. They had the other 3, and the other 3 are on the stove. So let's identify which type of cooking is which and the different things that we need to pay attention to when we have cooking problems. And then we'll get into the induction cooktop and how the induction cooktop works and what's the difference between all the other heating styles that we have here. Conduction. Which type of cooking do you think is conduction? The top of the stove, the baking, or the broiling?
The top.
The top of the stove. So what does it mean, conduction?
The transfer of heat through direct contact?
Yeah, the direct contact. So we can start off with a typical coil burner, all right? And when we turn this on, this element gets red hot on high, and we put our frying pan on top of it or a pot on top of it, and a majority of the heat is conducted from the element to the pan, and it's the actual heat of the pan that cooks the food. So if we don't have a good solid surface on the bottom of our pan, either the elements warp, damage, or whatsoever, we're not going to have good cooking results. The problem with an element like this is, like we say, conduction, but in between each one of these coils, there's a gap. And so there's no heat being transferred from here to your pan, so you got a spot that touching the bottom of your pan is creating a lot of heat. Then you have a gap to the next loop here, so you actually have a different temperature between here and here in that space. Now when you're looking at it, it has to be flat, okay? There can't be no gap from each one of these. And right now, I'm touching it, and if you look at this cardboard, is it touching every one of those loops on the bottom?
Yes.
It is? I think I can actually see some of those loops, pass it around, some of those loops are not touching that edge of that cardboard. So that means, even if your pan is perfectly flat, I'm not gonna get the best cooking results. So when they make these, I went to a GE factory one day, and they have this long metal tube, like this. And then what they do in the factory is they take a wire and they run a wire down through it like threading a needle and coming out the other end. That wire is what's actually carrying electricity. So if you were to touch the outside of the element, you would get burned, but you wouldn't get shocked electrically. So we have this rod running down the middle of it, the current's flowing through that. Around the outside of it, they fill it up with like a magnesium or some other insulating material. It's like a powder. And then if you look closely at the element where the metal prong comes out, they'll have like a little rubber stopper that they shove in the end here and they shove in the end here. Once they do that, and they pull that wire tight and they run down the tube, they try to get it perfectly centered so it doesn't touch the outer wall. If that wire touches the outer wall, we have a ground or a short. Okay? Sometimes in the bake elements or broil elements in the oven, and few times it happens on top of the stove, you'll see an element go bad and it'll have holes blown out of here. And what happened is when they formed this, either it was too close to the edge here or there, eventually the heat broke down the insulation and then it touched the metal and then it blew up like an electrical arc. It blew holes through the element. Now the element's no good. But this is a perfectly round tube. So once they pull this tight and they pack the ends in, they got a machine that coils it around into the loops and makes all the bends, but it's still round. Once they do that, they take another machine and just slams it down, and actually the top of those elements are supposed to be flat. So when you look at this element, you look at the other side, underside of the element, you'll see it has a curved edge. You look at the top, and it's flat. So they have a machine that takes this which would be a straight tube, like a copper tubing or something, it coils it all around, and then they stamp it under a lot of pressure to flatten it out. Problem is, sometimes that little wire in the center could be too close to the edge, and we get a damaged element. Now, when they make these stoves, they run them through assembly line, they actually hook them up to power, and they test them all out to make sure that when it's sold, that it doesn't short out in the customer's house. And they actually have a machine that tests it for very, very close grounding tolerances to make sure that doesn't happen. So this is a standard coil burner, and it does cook, but it takes time for the heat from here to transfer to the pan, and from the pan to transfer to the food. It takes time. So it does work, but depending on the size of this burner is depending on our cooking results. We have different types of pans. We have a pan with an iron core or stainless steel flat bottom. We have a pan that's like a copper type of pan, and then we have a pot here that's aluminum. Does the type of material make a difference the way you cook? Yes. Yes. So out of the three, which one would give you the best cooking results?
The iron.
Which one?
Iron.
The iron or the stainless steel, because it will conduct the heat more. You know, if you cook something in the oven with aluminum foil, you can almost grab the aluminum foil and take it out of an oven that's been baking at 350, because aluminum doesn't conduct the heat too well. It's more of an insulator than a conductor. It doesn't transfer the heat as well as the steel will transfer. Copper is a little bit better, but steel is the best. Okay? So, that's conduction. What do you think is convection?
Oven.
Baking.
Baking or broiling?
Baking.
Baking. Well, what does that mean? Oh, now it shows up. What does that mean? Convection.
There's heat everywhere with the fans.
It's heat with a fan.
There is convection cooking with a fan in it, but it necessarily doesn't have to have a fan. Yes?
It's something to do with the air being
It has
heated
to
around
do
it.
with the flow of air. Now, the fan forces air, that's a forced convection. But in this case, we bake using the bottom element, sometimes adding a little heat on the top to even it out. But what happens is heat rises. So we have a vent on the top of the oven so the air can go out. And as that heat rises, it pulls air in. So when we're cooking, we have a natural airflow through the oven. So that is convection. It's the natural airflow of the oven. So that's when we bake. What is broiling?
Radiation.
Radiation. And that's like, you know, when you go to the beach and you lay down in the sand to get a tan, the sun's radiating the heat down on top of you. So when you're broiling steaks or broiling fish or something like that, it's radiating heat down, and you're only cooking the surface that is direct, not contact, but direct heat from it. So if you had a piece of steak and you're cooking it, you'd have to flip it over if you wanted to cook the underside. I mean, it will still transfer the heat, but you'd burn the top before the bottom get cooked. So you have conduction, convection, and radiation. Now, real quick, I was going to talk about the different types of cooking. Now, here we got a glass top stove. Is this conduction, convection, or radiation?
Conduction.
Conduction. Okay, so if I put this heat on here, or this pan on this here, which one would cook better? Would this one cook better, or the glass top stove cook better?
Glass top.
Why would the glass top stove cook better?
Even heat over across the whole surface.
Well, you still got heat across the whole surface with the other burner, but let me ask you a question. Between the actual heating element and your pan, what is there?
Glass.
Glass is a conductor of heat or an insulator of heat? It's an insulator. In the attic of your home, we put fiberglass. It's fibers of glass. Why do we put fiberglass in our attic? To insulate and keep the heat from the sun from getting in your house. So if you're putting a piece of glass between your burner and your element, is that the most efficient way of cooking? No, you're actually having to heat more and to use more electricity cooking with a glass top stove. People like glass top because it's easier to clean, but it's not the most efficient way of cooking. Okay? So let's talk about convection. So holiday time, we're gonna cook a turkey, you know? And we got the element down here. And the heat's rising up and it's going around like so. What are some factors that can affect the way you cook the turkey? Give me something that would affect cooking time or cooking quality.
The size of the
Open the door, the size of the turkey,
Not being defrosted enough.
covering the turkey,
temperature.
temperature.
The fan being broken, but that's just reaching for
Well,
skulls here.
This oven don't have a fan if you're just baking. Okay, we're not talking about forced convection. Okay, well, let's talk about this for a minute. When you're baking a turkey, the heat rises from the bottom. Now they say cook a turkey till you take a thermometer and you stick it underneath the leg of the turkey to measure the inside temperature of the turkey because the turkey's this big. Okay? Now, you want it to get to 170 degrees right here, and you need to cook it for at least 20 minutes at 170 degrees, 15 to 20 minutes. You cook a turkey, you put a thermometer in here. When that reaches about 170 degrees, you let it cook for another about 15 or 20 minutes, should be good to serve. Okay, it should be cooked completely through. But we got a problem. That turkey could be 6-8 inches thick. Let's say we bake at 350, 400 degrees. The outside of the turkey is going to get the temperature real quick, but you go 3 or 4 inches deep, do you think it's going to be as good? No. So what happens there when we're cooking, if we let it cook for about 3 or 4 hours, which is what it takes for a big turkey? Got to cover it. So, you know, they tell you, you take a piece of aluminum foil and you lay it over the top of the turkey. What is the aluminum doing? It's insulating the top of the turkey so it isn't getting direct heat. And it's allowing the heat to gradually get into the center of it. Slows the outer process. If you leave it uncovered, the outer part of the turkey would be burnt before the center part of the turkey is cooked. Okay. Why are we talking about this? I mean, you know, this is a class on how to fix ovens and how to fix appliances. I'm telling you, this is how you cook a turkey.
To fix it, you have to know how it functions.
If you don't know how to use it, how do you know if the customer is complaining, I'm cooking my turkey and it's not coming out right? If you don't know how to use the appliance, how are you going to tell if it's a problem with the appliance or a problem with the customer's use of that appliance?
They don't know
Okay,
how to cook.
so you don't have to be a chef, but you might need to know a little bit about how to cook properly. Because if a customer calls you out and says, you know, my turkey came out fine, I had it covered, checked the thermometer every now and then, I scooped up, sprayed a little bit of the juices on to keep it moist on the outside, you know, and I got to 170, it was perfect. So while everybody's eating, I threw some cookies in there. And I had 2 pans of cookies. And one pan, the bottom of my cookies were burnt, and the top of the cookies were still sort of doughy. But the top pan was cooked on top, but the bottom of the cookies were a little doughy. What did the customer do in her oven?
It's not cycling right.
They stack them.
No?
It's broiling instead of baking.
What?
They stack the cookies directly on top
How's the
of each
bone?
other.
Stack the 2 racks of cookies on top of each other. So if you got an oven like this, and you got a rack in here and a rack in here, you put one rack to one side and you put another rack to the other side. It's all right if it overlaps a little bit, but you want to have natural flow. Because remember I said when we cook the turkey, we put foil over it so we don't overcook the outside. Well, if I put this pan over this one, that heat comes up, and if I have the pans directly over, the bottom of the upper pan doesn't get enough heat. So it goes around, yeah, it gets some, but the pan's shielding. Have you ever been to a campfire or something like that, and you stand next to the fire, you feel the heat? Someone walks in front of you, and it's not as hot until they pass by. The heat is radiated to you, it's blocking that heat. Okay? So if you put them like this, the top of these cookies will cook better than the bottom, and the bottom of these cookies will cook better than the top if they're directly over. So you have to stagger them. Some people in the holiday times got so many people over the house, they shove everything on, they fill up every rack.
That's good.
So what do you do to counteract the burning and everything? Let's say you only have one oven and you don't have a lot of space, so you have to put all this stuff in there. And you have to do it all at once because, if not, some stuff will get cold while the other stuff's cooking. So what could you do?
Switch it over.
You could rotate them halfway through. What if we just went to a little bit lower temperature, cooked for a longer time so that we're not burning part of it, we're letting the rest of it catch up. So you have to adjust your temperatures as well as your cooking times. I remember when I first started doing this, I started working for Sears when I was 17. I remember this little old lady. I come into her house and she was cooking 2 cookie sheets right on top of each other like that. And I tried to explain to her, ma'am, you can't do this and that. First thing she said to me, Sonny, I've been cooking since before you were born. I wasn't rude, but I said, well, ma'am, I went to a school and was trained how to do it properly. I understand you were cooking since before I was born, but did you ever have a proper class on how to use this?
Wow, I like this.
I'm here to help you.
I like this part.
But you have to watch how customers say to you, and you can't be rude back, because all they're gonna do is kick you out of the house. Okay? So, it's important the way you stack them. If you have a convection oven that has a fan inside of it, staggering them is not as important as if you have a natural convection airflow. Some of these stoves, like this one here, the vent is on the top behind here. If it's a regular coil burner like this, the vent is usually underneath this left rear burner. What do people like to do in Hialeah? They cook so much, what do they do underneath these burners? What do they do to the pans? They wrap the pan in aluminum foil because they don't want the grease to get down there. Well, those pans have a little hole in the middle of them. They cover the whole bottom of it. Well, it causes 2 problems. The hole on the bottom is so that airflow can come up and we have a good airflow through it. But the oven vents through this rear burner. If you cover it with aluminum foil, you have that vent here running underneath that burner. You block that vent, you change the way the air flows in the oven. Now, if the lady's trying to bake a cake or bake things where airflow is important, she's going to get poor results. Now, I'm not going to get too deep into it, but actually cooking pans. If you have brown cooking pans versus shiny cooking pans, dark pans cook faster than shiny pans.
Reflect.
The shiny pans actually reflect the heat more than the dark pans.
Same goes for like how, like if you're outside and you're wearing a white shirt as opposed to a black shirt, the sun would actually reflect off the white shirt and the black would actually absorb the light from the sun. So you'll get hotter in a black shirt than opposed to like a shirt on a white.
And that's the same principle. So
Yeah.
natural convection is important. Now radiation, again, sticking stuff in there when you're broiling, the oven door has a broil position. I don't know if any of you guys realize that, if you open up your oven that far like that, that's for broiling. We don't broil with the door closed. We have to watch our food. First of all, you want the racks higher up to the elements. You don't want them in the middle of the oven. It's too far away. Broiling is like heating it fast. You go into a commercial kitchen, they have something called a salamander. A salamander is about this long. They're usually high up, but they have heat radiating from the top, and they take the pan, they stick the pan in there. When you go to Chili's and you order those fajitas, okay, you go to Chili's and you order those fajitas, what happens when they walk through the restaurant? There's sizzling and steam's coming up. How do you think they created that? They have it in the salamander. They're blasting it with heat, and they take it right out of that salamander and bring it to you while it's cranking. Okay, so when you're cooking, you put it on a higher rack, but you're really close to the element at the top, so you have to be careful of a couple of things. You know, steaks and stuff like that splatter grease, you can catch a grease fire or whatever. We are not baking and trying to maintain an exact temperature in an oven when we are broiling. That's why we have a broil position on our door, so we can watch what we're cooking. We're not supposed to walk away from it because it is dangerous and a fire hazard. Okay, so you have to know how to use these different types of cooking. Alright? Induction. I got 2 quick videos on induction that I'm going to show you guys the videos. On the website, what I'll do is I'll post the links to those YouTube videos on induction, and then I'm going to go over the questions that you guys did and talk a little bit about it, and we're going to do our own demonstration in class and look at this one induction cook temper we have open. Okay?